If matrix A is a 6 by 3 matrix, what is the largest possible dimension of the row space of A? What about if A is a 3 by 6 matrix? What is the largest possible dimension of the row space then? And explain. So, what is the dimension of the row space of matrix A? Well, we know by the rank theorem that the dimension of the row space of matrix A is equal to the dimension of the column space of matrix A, which is equal to the number of pivot columns. So we are being asked here, what is the largest number of pivot columns? So part A, or part 1, suppose that A is a 6 by 3 matrix. So what is this telling us? This tells us we have 6 rows and 3 columns. So we can say that since matrix A has 3 columns, it can have at most 3 pivot columns. Now, if we go ahead and assume that each one of these 3 columns is in fact a pivot column, then therefore the largest possible dimension of the row space of matrix A is 3, because that is the largest possible number of pivot columns that this matrix can have. Now, what about if we take the transpose and suppose that matrix A is a 3 by 6 matrix? And so what is this telling us? This tells us that matrix A has 3 rows and 6 columns. So we can make a little love note here to ourselves that, giving ourselves more room first, that matrix A has 6 columns, but matrix A only has 3 rows, which means that matrix A can have at most 3 pivot positions. So assuming that each one of these pivot positions is a pivot column, then therefore the largest possible dimension of the row space of matrix A is 3. And this is our beautiful final answer.